Welcome to Introduction to Procedural Analysis, Understanding Methods, Techniques, and the Applications. My name is Luis Gutierrez. In the next 20 minutes, we'll be exploring the methods, techniques, and applications of one of the many task analysis approaches found within Johansson and others' 1999 book, Task Analysis Methods for Instructional Design. Following this lesson, you'll be asked to take a short assessment to measure your understanding of the material covered. So please pay attention, take notes, and follow along as this lesson proceeds. Introduction. As an instructional designer, you'll be asked to make large problems small, and nothing does this better than using some sort of task analysis. This is why today we'll be diving deep into the world of procedural analysis and understanding how this systematic approach can help us break down complex processes into simple, manageable steps for better decision making and problem solving. The goal of this lesson is to introduce participants to the concept of procedural analysis, including its methods, advantages, disadvantages, the context of use, while providing some meaningful examples to help you, the learner, conceptualize this method further. Learning objectives. By the end of this lesson, you'll be able to define procedural analysis, identify its methods and techniques, evaluate its advantages and disadvantages, recognize its application across various contexts, and apply these concepts through real-world examples. So what is procedural analysis? Procedural analysis is all about breaking down complex processes into smaller, understandable steps. It's like dismantling a complicated puzzle into its individual pieces to see how they fit together. This skill is important because it empowers designers to create learning experiences that can effectively guide the learner through complex concepts or tasks. To do this, designers have various methods and techniques available to them under procedural analysis. In this class, we'll be covering two of them, flowcharts and decision trees. Each of these methods offers a unique way to visualize and analyze processes that ultimately lead to making informed decisions. Starting with the flowchart. Flowcharts are graphical representations of processes or workflows that use symbols and arrows to illustrate sequence of steps. They are versatile and can depict various types of processes, from simple to complex. Flowcharts use different symbols to represent different types of actions, decisions, and connections. The circles regularly represent inputs and exit points, whereas rectangles mainly represent actions or tasks needed to be accomplished. Lastly, diamonds tend to represent decision points. Note, each flowchart may vary and require different symbols to help out the designer. Ultimately, flowcharts are especially useful for visualizing the decision-making process, identifying bottlenecks, or optimizing workflows. Moving on to decision trees. Decision trees are hierarchical diagrams that represent decisions and their potential consequences or outcomes. They consist of nodes, branches, and leaves, where nodes represent decisions, branches represent possible outcomes, and leaves represent final outcomes. Decision trees are commonly used in decision analysis, risk management, and classifying problems in machine learning. They provide a visual and systematic approach to decision making, helping users evaluate different choices and their associated risk and reward. Let's break down the advantages and disadvantages of procedural analysis. Procedural analysis offers several benefits. It helps us understand complex processes, improves communication among stakeholders, and enhances decision making by providing a structured approach. However, it's essential to acknowledge the drawbacks. Procedural analysis can be time-consuming, may oversimplify complex situations, and require regular updates to remain relevant. It's important to understand this method's strengths and weaknesses, since you may find yourself having to pair this analysis with others to close this gap. Context of use. Procedural analysis isn't limited to just one industry or field. It finds its application in various environments, including business operations, software development, healthcare, legal procedures, and engineering. Let's explore how it's utilized in two examples. Example 1. The use of flowcharts in business operation. Here we have a flowchart for supply chain managers needing to optimize his or her supply chain operation process. By using procedural analysis, we can break down the entire supply chain process into smaller, more manageable steps and pinpoint any bottlenecks within the process. Starting from the top, with the circle representing the start point, you can see some of the various tasks needed to be done as a manager. Focusing just on the supply chain operations specifically, we move down past the monitor inventory icon to see where this process takes us. Immediately, we are prompted with a decision point that asks, is the current inventory low? A no will lead you down to the end of this process, while a yes will demand that an order be placed to ensure proper inventory levels are met. Moving forward, once the order is received, we are prompted once again with another question. Is this order accurate? A yes will lead you down to the end of this process, while a no will ask you to place another order or reorder the same merchandise. As we can see, this approach has provided us with several outcomes. 1. A graphical representation of this process. 2. Made a complex process simple to understand with the use of different symbols. And 3. Helped us identify a potential bottleneck. Notice that in this example, we can see an endless cycle of inefficiency happening between receiving the merchandise and the manager having to reorder every time the shipment is incomplete. This issue may require further investigation and perhaps demand additional steps be added to the flowchart process in the future. Note the disadvantages to this approach. 1. It's time consuming. You can only imagine how long this flowchart can get. 2. It oversimplifies. There's perhaps many sub-steps and missing nuances not covered. And 3. It requires recurring updates, which again can be quite time consuming. Let's try another example. Example 2. The use of decision tree in healthcare. Here we have a decision tree for optimizing healthcare diagnosis. By using procedural analysis, we can break down the process into smaller, more manageable steps, and thus help healthcare professionals make better and more informed decisions. Starting from the top, symptoms begin to branch out according to temperature levels to help healthcare professionals decide which course of action to take. A fever of over 101 degrees Fahrenheit would take them down the left side of the decision tree, while one under 101 would take them to the right. If we follow the fever of 101, we are met with another branch that either takes us down the cough or headache path. The patient in this case has a headache, along with a stiff neck that, according to the model, prompts us to do a bone scan to diagnose the situation further. Notice how this process can continue on practically forever, yet it accomplishes its main objective: to classify the problem with the information provided. Let's take a look at our decision tree checklist. This approach provides us with a hierarchy to work with, added with nodes, branches, and leaves. And it successfully classified the problem by providing the healthcare provider a simple course of action to follow. Much like the model before, this approach is time-consuming. It may oversimplify the task, and in this case, in the healthcare field, it may be detrimental to the patient. Lastly, this model requires recurring updates that again adds more time to the already taxing process of building a decision tree. Before closing this lesson, I would like to take a minute to highlight some of the characteristics of procedural analysis that go beyond the scope of this lesson, but are nonetheless worth mentioning, to give you a wide-range view of the method's place among its peers. Starting with theory, procedural analysis assumes that what is being described is an observable behavior, or as Jonason and others describe it, overt steps. Therefore, procedural analysis should not be confused with its near-peer method, information processing analysis, covered in another lesson, which looks at the cognitive or covert steps of this model. Though it must be noted, there are some situations where they do overlap. Moving on to task analysis. The term task analysis, according to Jonason and others, tends to assume that it combines various methods into one, particularly in part 2. But a closer look reveals to the contrary of the title's messaging, job, procedural, and skills analysis method is actually 4 separate methods as depicted on the slide. Each method is distinctly different from the next and can provide vastly different information depending on which one you choose to use. You may even find yourself combining these methods in the future. Lastly, the algorithm method is worth mentioning. Similar to the flowchart and decision tree, technology has enabled designers to use computer programming to simplify this labor-intensive process of procedural analysis. The algorithm method, in its simplest form, is a programmed step-by-step process of instructions for solving problems. They are time-consuming to create, but greatly reduce the time needed to analyze various tasks. Algorithms can be expressed in various forms, including pseudocode, flowcharts, and programming language. They are the backbone of computer science and are used in a variety of applications, including software development and data analysis. I would ask that you keep these added notes in mind as you build your analysis in the future. Remember, instructional design, along with this task analysis, is an evolving field. So let's recap. What have we learned? What we learned is that procedural analysis turns complex processes into simple steps. By using such methods and techniques as flowcharts and decision trees, you are able to visualize through graphical representation what each process or workflow will look like to solve problems and make better decisions. We have evaluated the advantages and disadvantages of this approach, mainly by depicting the advantages as improving communication and enhancing decision making, with the added disadvantage of being time-consuming, too simplistic, and requiring recurring updates. We also reviewed context of use. Based on our 2 examples, we saw that this model can be applied to business decisions in a supply chain scenario, and in healthcare, where a diagnosis can save a life. But furthermore, it can be used in a variety of fields, including the legal profession, software development, and engineering. In closing, as structural designers, you'll be asked to make large problems small, and nothing does this better than using some sort of task analysis. This lesson introduces you to the world of procedural analysis and to understand how the systematic approach can help you break down complex processes into simple, more manageable steps for better decision making and problem solving. Add this tool to your toolbox as you continue on your journey to becoming well-rounded instructional designers on a mission to improve the world around you. At this time, please complete the assessment on your right side of your screen to finish this lesson.